Hi, my name is Alexander Demetrio, and I will be doing cases 1 and 3. Today is June 9th, 2024, and this is week 3 of our case studies. So, first up is case 1. So, when it comes to regulation of pyruvate kinase, it is a crucial enzyme in glycolysis, and its activity is tightly regulated through various mechanisms to ensure proper energy balance and metabolic flux. And here are the main regulatory mechanisms. So we have allosteric regulation. Here, pyruvate kinase is regulated by several allosteric effectors, one being an activator, which is fructose 1,6 bisphosphate. Bisphosphate is a potent activator, enhancing PK activity to ensure smooth flow through glycolysis. And then there's inhibitors, like ATP and alanine, and they act as inhibitors, as said before, but they also signal sufficient energy levels or biosynthetic precursors, thus down-regulating PK activity to prevent unnecessary glycolysis. There's also phosphorylation. So in the liver, type L PK is regulated to reversible phosphorylation. So the inactive state, when blood glucose levels are low, glucogen stimulates a CAMP-dependent protein kinase, also known as PKA, which phosphorylates PKL, reducing its activity and thereby decreasing glycolysis. There's also dephosphorylation, which is the active state. Here, high blood glucose levels lead to dephosphorylation of PKL, activating and promoting glycolysis. Lastly, there's gene expression, um, which is the expression of different PK isoenzymes is tissue specific, and it can be influenced by various factors, including hormones, metabolic states. For example, insulin can upregulate the expression of PKL and PKM2 to enhance glycolysis. So next in case 1 is pyruvate kinase isoform expression in cancer cells. So cancer cells often exhibit a preference for glycolysis, the Warburg effect, even under aerobic conditions. The regulation and isoform expression of PK play a critical role in this metabolic reprogramming. So when it comes to isoform preference, cancer cells predominantly express the M2 isoform pyruvate kinase over the M1 isoform. And PKM2 has unique regulatory properties. That has regulatory properties that are advantageous for cancer cell metabolism. So, low activity state. PKM2 can exist in a low activity state, which slows down glycolysis at the pyruvate kinase step. This might seem counterintuitive since cancer cells are highly glycolytic. However, this regulation serves crucial purpose. And then for metabolic flexibility and biosynthesis, by slowing down the final step of glycolysis, PKM2 allows for accumulation of upstream glycolytic intermediates. These intermediates can be diverted from to various biosynthetic pathways necessary for rapid cell proliferation. For example, glucose 6-phosphate can enter the pentose phosphate pathway to produce ribose 5-phosphate for nucleotide synthesis and NADPH for reductive biosynthesis. Also, PKM2's low activity state supports the conversion of pyruvate to lactate rather than to acetyl-CoA, which allows glycolysis to continue regenerating NAD plus and supporting rapid ATP production on cytoplasm, albeit less efficiently than oxidative phosphorylation. Finally, the oncoprotein MYC is known to promote the expression of PKM2. MYC is a transcription factor that regulates genes involved in cell growth and metabolism, thereby supporting the metabolic demands of proliferating cancer cells. The preferential expression of PKM2 is a strategic adaptation by cancer cells to balance the dual needs of energy production and the synthesis of macromolecules essential for cell proliferation. So that's it for case 1. Let's move on to case 3 with these 4 questions, starting with, I really like to take long walks. Will I still be able to do this with my friends? Yes, you should be able to take long walks with your friends because glycogen phosphorylase deficiency affects the breakdown of glycogen to glucose in muscles, which is particularly important during high-intensity, short-duration activities. However, long walks are usually a form of low intensity exercises that primarily rely on aerobic metabolism using fatty acids and blood glucose as a primary energy source. So, as long as you pace yourself and avoid sudden, intense bursts of activity, you should be able to enjoy long walks without significant issues. So, next question: do I have to worry about having reduced muscle glycogen stores? Um, while muscle glycogen stores might not be utilized efficiently due to your deficiency, your body has other ways to produce energy. So during low to moderate intensity activities, your muscles can use blood glucose and fatty acids as fuel. It's important to maintain a balanced diet, though, with adequate carbohydrate intake to ensure you have sufficient energy available from other sources. Additionally, engaging in regular appropriate exercise can help your body adapt and become more efficient at using alternative energy sources. So, third question: as a result of this deficiency, will I need to get up at night to eat and to maintain my blood glucose levels? No, you should not. You shouldn't be able to get up at night to eat. You shouldn't need to get up at night to eat specifically to maintain your blood glucose levels, I should say, because of this deficiency. Glycogen phosphorylase deficiency affects muscle glycogen breakdown, but not liver glycogen breakdown. So the liver plays a primary role in maintaining blood glucose levels, especially during fasting or overnight. So your liver can perform its function normally to keep your blood glucose levels stable. And then finally, last question: do I need to worry about producing excessive lactate during intense anaerobic exercise? So, yes, you might need to be cautious about intense anaerobic exercise because during high intensity activities, your muscles typically rely on glycogen for quick energy. With a glycogen phosphorylase deficiency, your muscles cannot break down glycogen efficiently, which leads to early fatigue and possible muscle pain. So, without adequate glycogen breakdown, there is also an increased risk of producing lactate, which can lead to muscle cramps and discomfort. So, it's advisable to avoid very intense anaerobic activities and just focus on moderate or aerobic exercises. And these are my sources. Thank you very much.